guess I wanted to start off before I ask you for introductions to first of all thank Pamela from the Dow Tile Studio here for hosting and providing us with this space. A little tight, but cozy, and we've got a great view. So Pamela will be doing a tour of the facility after our session today. So if you're interested in looking around, see what they do here, it's kind of neat. Those of us who were at Fretz last week, got to see their showroom over there, and now we get to see this showroom here, so it's kind of nice. I also want to thank Elise from the BIA for helping us set this up and working with us on this facility and getting invitations out, etc. And also we have our friends from PICO here. Rick, here you are. Rick Gazik is here, and Rick will talk a little bit about the PICO program at the end of our session today. So let me get started a little bit. Brian, let's hope it did. This is me. Had a good day. A good day. Good day. I like the yellow ties. The whole basis for Energy Star and being better, and that's what Energy Star is all about, is being better, building a better building, is baselined on code. And the initial comment I want to make today is, we have been working with codes before there were codes. After the 70s oil thing, some of you are way too young, codes came into effect in various states, and particularly energy codes. So the first energy codes really came out in the early 80s. Those of you old enough they were called the BOCA codes or the CABO codes. There was a couple different codes out. But now we have the International Energy Code, the IECC, that we use. The city of Philadelphia and its environments have adopted the 2009 code, and that's great. The bad thing about the 2009 code in Philly and its surrounds is that no one enforces it. And those of you who are builders, you may not be asked for it by the local code official, city code official. That's understandable. But codes teach basics. That's the minimum. That's what you have to do. So the Energy Star program is based on that minimum. Now that minimum, has obviously been moving up the ladder, but the codes will deliver benefits. Hopefully, less energy bills, more money in the pockets of the homeowners, certain federal carbon standards, and all of that. But they can conflict with other codes, and I think that's what we're seeing. Certainly in the city of Philadelphia, those code officials are more interested in life safety issues like buildings collapsing and fire, and it's one thing to be uncomfortably cold, it's another thing to be on fire. You're really uncomfortable that way, so they tend to do that. So the codes can conflict with other codes. I'm really paying attention to this, so I really don't have attention. The bottom line, though, for you as builders and architects and designers is that regardless of whether the code official is asking you for that certification, that documentation, there is some documentation you have to do up front, and there's some testing that you have to do in the back end before you get a CO that's supposed to be done. It's not being done. You are still liable. I hate doing it. I hate to get these kind of jobs, but we do some legal expert witness work. And it always involves some sort of class action lawsuit by a homeowners association or a group of homeowners against the builder because they didn't do X, Y, and Z. And when the lawyers start digging, they start looking for all sorts of certifications. And we've come into a number of situations over the years where proper inspections on code enforcement with energy has not been done. So I just want you to be aware of this, that if you're not doing at least baseline code, then we have some issues.
So what we're going to talk about today, we're going to dive in a little bit of the history of Energy Star Homes, how it works, and then we're going to go a little bit technical, going through some of the requirements of Energy Star, specifically with the Energy Star checklist, which is a huge process part of the program, and then touch a little bit on the future of Energy Star Homes and just high performance building practices in general. And then I'm happy to take questions as we go, but we will have Q&A at the end as well. So just raise your hand if you have any questions. So this is kind of a snapshot of Energy Star Homes and where they started and where they are currently. So in 1996, Energy Star had what was called Energy Star Homes version 1. And the program was focused a lot on air sealing, duct sealing, and incorporating efficient HVAC systems and high R values and good performant windows as well. And they've always had, as an aspect of Energy Star Homes, a third-party verification piece. So where there is a third party who's doing inspections, doing the testing for air sealing and duct leakage. And then in 2006, they came out with Energy Star version 2. Because as codes get tighter, Energy Star has to respond because they always want to be an above code program. That is the idea of it. So at that point, they introduced not only air sealing but air barriers and how to align your insulation with your air barriers. They introduced proper sizing of HVAC equipment. Started to look at getting high efficient water heating and lighting systems in these homes. And they also switched to a checklist type procedure, and at that point they introduced what was called the thermal bypass checklist. So it was a checklist that guided you through all of the mandatory air sealing requirements of the home, essentially. And then in 2011, again, codes were ramping up, so Energy Star released version 3, which is what we're going to talk about today. At that point, they introduced some pressure balancing requirements, minimal thermal bridging, which we'll talk about all this more stuff in detail, introduced concepts about water management, and again, they've expanded upon their checklist of what was originally the thermal bypass checklist to multiple checklists, which we will talk about throughout the presentation. So that's just a snapshot of Energy Star, and with the idea that Energy Star wants to control airflow in a home, they want to control thermal flow and moisture flow as well. Those are the three kind of flows that they're looking to control. So that's where all these requirements that they've developed were focused in on. So 2015, I believe, is going to be the 20th anniversary of Energy Star Homes. It's a program that's had over 1.5 million certified homes, over 16,000 builder partners in the program. McGrain Associates ourselves, we were an original pilot partner at the early stages of Energy Star, and we ourselves have worked with and certified over 55,000 Energy Star homes. So the general program requirement and concept of Energy Star homes is to have a home that is independently verified to achieve at least 15% energy efficiency savings over a home built to the 2009 code. That's currently what version 3 is designed around. So Pennsylvania right now, 2009 IECC is applicable. So Energy Star version 3, again, is to be 15% better than that. That is the concept there. And it's all centered around what's called the HERS index. I'm not sure if everyone here is familiar with the HERS index, but the HERS index is a scoring scale that was designed to essentially be like a miles per gallon tag on a home. So, everyone's familiar with cars and MPG rating. So the HERS index was developed to be that kind of scale. And the concept here is it's a scale of 0 to 100. It can go above 100, but each point below, so if you have 100 and then 99, 98, each score one below represents 1% savings better than the standard new home of 100.
It's kind of like a golf score.
Yeah, the lower the better. That's correct. That's a good way to put it. Yeah, so we're trying to drive down, and the idea with a 0 score would be a zero energy home, where you are offset in all of the energy usage through renewable energy, such as PV, things like that. So Energy Star in version 2, they were around 85 was kind of the point where you had to be below. At this point with version 3, they've made it a little confusing because now it's more of a custom target depending on which home. But typically we find them being in as high as like the mid 70s to the low 60s, high 50s. So it's kind of varies depending on where you're at. But this is what the program is designed around. It's one of the key components of Energy Star.
Yeah, we just had one come in a couple weeks ago. We saw it our HERS score was 22 or 23. So when you get down into those areas, you're definitely speaking of renewables, solar, wind, geothermal, to get those kinds of scores. But it's certainly doable.
Yep, absolutely. And some of the training requirements around Energy Star has also introduced training requirements. For a builder to be a partner, for instance, they would have to do an hour-long online orientation course. The raters, that's what the role McGrain Associates plays a lot. They have to go through an Energy Star rater training through an accredited provider. And there's a test at the end that they have to take as well to work under Energy Star homes. One of the bigger kind of training requirements has been focused around HVAC contractors. So there's actually a credentialing program through various organizations or participants where an HVAC contractor would have to be credentialed through one of these organizations in order to work on an Energy Star home. So that all these different training requirements have been introduced, and you can find more information on the Energy Star website if you have any questions about that. So the concept of Energy Star version 3 is you have what's called like a reference design where you can go performance or prescriptive. It's kind of a set of measures that you want to accomplish. You want to incorporate efficient heating and cooling systems, an efficient envelope, lighting and appliances, water heating. So the performance path is focused on driving that HERS index down, and the prescriptive path is a set of strict measures. You have to do X, Y, and Z. And on top of that, they have mandatory checklists. So there's one focused on thermal enclosure, how good of a built-in envelope does the home have. 2 checklists focused on HVAC, how well the HVAC system was installed and is operating. And then a 4th checklist focused on water management and making sure that the moisture flow is controlled and water can stay away from the house. So the process as it is there's 2 paths to Energy Star certification. You can go the prescriptive route, which is you build the home following a mandatory list of measures, and you complete the inspection process. You partner with a verifier to go through the inspection checklist, and at the end you'll get your Energy Star label. Then there's the performance path where you can model the home through an energy model and accomplish the HERS index that you need to achieve. And you can mix and match. You can maybe do a better heating system, but you can save some money and not do a higher efficient water heating system. It's more of a flexible trade-off way of getting to Energy Star. And then again, you complete the inspection process with your verifier, your rater, and you can and then you'll proceed to get your certification. From our experience, most people stay away from the prescriptive path. Because it sounds easy, but once you look into the actual prescriptive measures, a lot of builders, architects, homeowners, they want to have a little bit more flexibility, more options. So I'd say 99% of the builders that we work with end up going the performance path, where they can trade off various different types of values.
So 2 quick things. PICO program only accepts performance path homes, and actually in June of this year, EPA is sunsetting prescriptive path. So
there you go. That's great news then. So that's right. So forget about the prescriptive path, which is great because all we're going to talk about is performance path anyway. So the performance path process. What does it involve? So there is a initial HERS index target score. So you model your house, and the model will tell you for Energy Star you need to get a HERS 65, for example. And then you can mix and max upgrades in your house to make sure that you get your home to a level of HERS 65, essentially. They also, in terms of incorporating that, what is your target score, they have what's called a size adjustment factor. So one of the inherent flaws of the HERS index is the bigger the house, the easier it is to get a lower HERS index score, which is, intuitively, the opposite of energy savings aspect. The bigger the house, the more energy it's going to use. So EPA, in order to kind of offset that effect, introduced a size adjustment factor, so it's more of an even playing field. So the bigger the house you are, the lower the score you have to get, essentially.
Yeah, there's an interesting sidebar on that because with the size adjustment factor and multi-generational, new new type of families, multi-generational from immigrant families coming in where, you might have 3 families in a 5,000 square foot house, 3 generations. Is that better than having 2 homes? Is it better having 1 big home with 3 families or 2 homes or 3 homes with those generations? So there's always that philosophical conversation we have with EPA about what do we do with these, as they're arising, particularly in the city and urban areas, these larger urban multi-generational situations. And it's kind of a little bit of a technical and philosophical dilemma.
So this is the size adjustment factor. I'm not going to get into the math here, but just to give you an example, a 3,000 square foot home might be reduced, their target might be reduced from 80 all the way down to 72 for a 3-bedroom, 3,000 square foot house. So that's kind of the impact you can see if you're building a home that's larger than these benchmark size homes. So the performance path process, you do your energy model, you get your home down to the HERS index you need. Now you got to focus on complying with the 4 mandatory checklists of the program. So the first checklist is what's called the thermal enclosure checklist. This is a checklist that is completed by your third-party rater that you would need to contract with. The rater is they're empowered to use their experience and discretion to verify those items on the checklist. Sections 3 and 5 of the checklist are carryover items from the previous version of Energy Star, version 2. And then they've added 3 new sections, 1, 2, and 4, which are focused on windows, insulation values, and minimizing thermal bridging, which we will talk about. So section 1 of this checklist is focused on making sure that there's high performance windows. So we talked about how there is trade-offs with the performance path. Windows is one where they do not allow trade-offs. So they have a set requirement on the thermal enclosure checklist stating that you have to install at least the prescriptive values of the 2009 IECC windows in your home. So I believe for this climate zone that would be a U factor of 0.35 or lower, essentially. Section 2 talks about insulation. So there is a prescriptive measure of how much insulation you have to install, and then a requirement around how well it is installed. So again, there's trade-offs in the performance path, but they, at a minimum, want to make sure that you're putting in code-compliant insulation. So they're not going to allow you to do less insulation than the code and make it all up through heating and cooling and water heating. They want to make sure that you still have at least a minimum code-compliant insulation. And then not only how much insulation you're putting in, they want to make sure that that insulation is installed well. So ResNet, who is the organization that developed the HERS index, they have a grading system for insulation installation. So a rater can come out and would assess the insulation and assign it either a grade 1, a grade 2, or a grade 3. So we will talk about that in a little bit. So the 2009 IECC, as far as insulation values go, Philadelphia is climate zone 4. There's other surrounding areas in Pennsylvania which are 5, so I highlighted both of those. So these are the kind of values that we're looking at. Ceilings, we're looking for R38, floor values, 19 or 30, depending on what climate zone you're in. Walls, if you're in Philadelphia, you're looking at R13. If you're in climate zone 5, some of the northern areas, you're looking at R20 or 13 plus some continuous insulation. So, they reference this 2009 ICC insulation value. So these are the values you would want to, at a minimum, start with for an Energy Star house. So getting back to that grading of the insulation, which I was talking about. So again, we have a grade 1, a grade 2, and a grade 3. So grade 1 is essentially you're installing the insulation per the manufacturer's specifications. So for bad insulation, you want it to be a complete blanket in between each stud bay of that house. So we don't want it to be compressed here or missing here, or you have a wire running through it and stuff behind it. That bad insulation needs to be fully filling that cavity. And there's ways to accomplish that through cutting around different types of penetrations. Grade 2 allows some compressions, so it's an average job of insulation, so you can have some compressions. And then grade 3 is just the absolute poor job of insulation. So Energy Star requires grade 1, or they allow you to get away with grade 2, which I wouldn't recommend anyway, because you want to get what you're paying for, if you have some continuous insulation on the outside, which we'll talk about in a little bit.
One of the things about grade 1 insulation, when Brian will show us the photos, is that the transition from doing batt insulation in the walls to foam insulation almost assures you that grade 1 insulation. Unless the foam installer really makes a mess of it, it really gets you to grade 1 a lot less expensively than trying to go back and refit that.
So here's some pictures of grade 1. Here you see a spray foam job. You know, spray foam is a lot easier, again, as Mark was just saying, to get to grade 1 because it naturally fills that cavity, and if there's a wire or an outlet, it'll fill all around it. There's a blown-in cellulose job right there, which again fills and naturally fills those cavities in. Here are some batt insulation. So with batt insulation, it's a lot easier if you're face stapling that batt insulation to the studs. Because if you're doing inset stapling like here, you got to do a really good job of making sure that you're not, pushing that inset staple in a lot, because then at every stud bay you'd have a huge, it'd add up, you'd have a little compression there. So, inset staple, face stapling versus inset stapling, friction fit batt insulation, cut in the batt insulation. As you see here, it's a full blanket. This is the kind of things we're looking for here. Section 3 of that checklist talks about, fully aligned air barriers. So we want your insulation and your air barriers to be fully aligned so that we have a tight house. So the different types of spaces that we're talking about, where you have a bonus room that goes above your garage in the upper picture here, where that house, that floor space above stops. You want to have an air barrier there, and this would need to be sealed in place so your insulation would align with an air barrier on the edge there. Behind your shower and tub is a classic one. If you're not familiar with Energy Star or these types of requirements, that can often get missed. So by the time the shower and tub gets installed, sometimes there's no insulation in that bay behind it. Or sometimes there's insulation in there, but there's no internal air barrier there. So working with your processes to make sure that, before that tub goes in, you have that insulation installed and you have that air barrier installed behind that tub is critical. On the back side of attic knee walls, sometimes you'll see batt insulation on the back side of an attic space. And then if there's no air barrier on the back side there, you'll come back a couple years later and that batt insulation's fallen down. It's not even there anymore because it's not gonna maintain contact there. So a fully enclosed air barrier there. And then just all your exterior walls, you want to have all your insulation, you want to be in contact, especially in walls, with your internal, your sheetrock, your external boundary, top and bottom plates. You want to fully have that enclosed to get the best, best air seal, and also your insulation will operate best that way. Cantilevered floors, you have floors that will jut out over outside conditions. Again, you want to have that air barrier on the inside there, and the bottom and the top, enclosing that batt insulation. Floors over a garage here, you want to, again, here's that where the house above extends. You want to have that air barrier where that house at the second floor terminates there. Same thing here, you have that block in there where that floor above goes, and it's also sealed in place. So those are the kind of things we're looking for there. In the attic, at the attic eaves, we want to see these attic baffles, which would go here and would go up and above the insulation, so it allows wind to come up and above the insulation, so you're not going to be blown in insulation in the attic there, as you see a picture there. We have drop ceilings and soffits down here, so sometimes you'll have a drop ceiling, and then oftentimes people will forget to have the air barrier go across here because you're not sheetrocking that space and not something you think about. So you want to make sure you have your air barrier keeping that space all within that pressure boundary. Same thing on the vertical here. This is a multi-family picture, but if you picture this as an exterior wall, you'd want to make sure again that blocking is in place there.
Can I ask a technical question?
Yep.
So oftentimes we'll call out for like the drywall to be continuous in areas like that. But if if they did, like a builder doesn't want to do drywall, like what other products are acceptable as an air barrier when you're transitioning from drywall to another product?
Well, anything that's durable and solid and will block air is
Thermoplastic.
thermoply, OSB,
Okay.
anything like that. Yeah. We some builders will try and use flexible air barriers. We're not a big fan of that, so I would always recommend something rigid. Something that's going to be durable and be able to block that air there. And then again, you need to seal it in place too. You can't just put it there. Also need to have the foam or caulk or whatever in between those gaps there.
When we first started working with builders and their subcontractors on these little details, the prices that my builder clients were getting were like phenomenal. We're like, oh my goodness, and, it's going to take this much and that much to do it. And then over time, when they realized it was part of their pattern and their scope of work, and it was a regular thing to do, the prices on the next job came down and came down and came down. So it may seem to be a little bit of a leap, your first couple units or your first project or so, but once the subcontractors, be they the framers, the plumbers, electricians on getting the other stuff done, the price comes down on it and works pretty well.
Insulated, so here you have an attic slope wall here where this bad insulation is installed here. And when you install your sheetrock here, you see, the bad insulation is pushed back there. So you're going to have, a full, 3-inch, 2-inch gap there between your internal air barrier, which is your sheetrock in this case, and your bad insulation, which is not what you want to see. You want to see that bad insulation fully out to where it's going to be in contact with that internal sheetrock air barrier in those instances. So, all different locations throughout the house this can be a problem. Section 4 of the thermal enclosure checklist talks about thermal bridging. So thermal bridging is locations in the house where you are unable to insulate due to framing, for instance. So everywhere where there's a stud, obviously you can't insulate. It's just a thermal bypass where through conduction you're going to have heat loss through that framing member. So Energy Star wants to incorporate features in the home that reduce those amount of areas, so you're not having all these areas where you have that thermal bridging. So there's a bunch of different ways to comply with this. You can incorporate what's called optimum valued engineered framing. So that's looking at specific locations of framing and utilizing certain framing techniques to limit the amount of framing you are, so you can insulate in a lot of these areas that become problematic. And we're going to go into detail on a little bit more of these. You can incorporate on the outside of your house insulated sheathing. So if you essentially wrap the house in rigid foam insulation on the outside of your house, you're at that point covering all of those thermal bridging through your framing members. So that's an option. And the other benefit for that is your insulator is held to grade 2 standards for insulation. But like I said, I would always still recommend that you would shoot for grade 1, because that's what SIPS panels, which are foam board sandwich that are structural. ICFs, insulated concrete forms, which are insulated concrete walls. So it's one of those those options. You'll pick one, and you can mix and match. Maybe you're having insulated sheathing, but the wall between the house and the garage is just going to be optimum valued engineered frame, and that's fine. And then on top of that, in this section, they have some requirements around uncompressed insulation in the ceiling and slab edge, which we'll talk about as well. So first option, like we talked about, rigid insulation sheathing, where you're wrapping your house with insulation. This is becoming more and more popular as the prices get a little bit more affordable for this. So we always try to encourage the builders to explore this option as your first option, because it's just a lot easier. These are the SIP panels we were talking about, where you have your exterior and interior sheathing sandwiched on a foam.
Can you go back? Are you doing a dew point analysis as to where when you're adding rigid insulation on the outside, that's not cause a condensation problem within the wall cavity?
So that's a good point. So if I was, we typically don't do that. I think I just popped it off. So We typically don't do that, but if an architect or someone, I would definitely, you'd always want to keep that in mind about as you add insulation to the outside, you want to know where that dew point is. That's an absolute good point. So,
Do those panels breathe as well? Are they permeable or non-permeable?
well, it all depends on the the facing of the type of insulation and what type of insulation you're using.
Because the vapor drive from the inside could end up condensating on the inside face of that exterior panel, right?
Yeah, these are very good points, and the philosophy of creating a wall system for us is to not allow any interior moisture, the moisture drive when you're pressurized, to move the moisture out. And then anything that's trapped during the construction process, things just normal drying out, would basically move outward.
Well, it won't if you wrap it with a non-permeable sheeting.
Almost
correct?
all the materials that are wrapped with are like a Tyvek type material that allow the moisture to move out without allowing moisture to move in.
But a foil-faced foam panel won't do that, right?
Well, it depends on that foam panel. Some of those panels are perforated, some aren't. So the green zip wall systems that you see around the city a
Right.
lot, that is permeable that allows the escape.
But that's not an insulating sheathing like a foil-faced foam panel, right?
No, not in terms, it has insulation value, but not to that level, correct.
Yeah, it's just OSB with a
But
press.
the whole idea for us is to make sure, and we haven't not had, fortunately, any issues with any Energy Star homes that we've worked on with any dew point situations in wall systems. Because the tightness of the interior wall and the thermal barriers that Brian spoke about earlier, in combination with the permeable house wrap on the exterior, has prevented any of that from happening.
That I understand, but Mike was specifically pointing out the rigid insulation sheathing, because it could be problematic.
Yeah, and those are all design considerations you want to take into your account, and for your specific location, all that I would absolutely recommend looking into that and making sure that you're not putting that house at risk due to something like that.
I was just gonna add too, like often when we've documented and built homes like this, the HVAC system is part of the overall consideration, because when you're doing rigid insulation on the outside and it's tight, it'll be designed to dry to the inside as opposed to the outside, because you're not gonna dry to the outside when you have rigid foam on the inside. So
If
it's
you're
just,
putting a
it's a
vapor
different
barrier on the
model.
inside, now you have a double vapor barrier, right?
But there would be no vapor barrier. Like the drywall would serve as like an air barrier, but not a vapor barrier
Understood.
necessarily.
Just
So-
asking a question.
No, it's a good question. So we talked about SIP panels. Let's move on to the more expensive and advanced products out there. Same thing with insulated concrete forms. We're seeing some of these, where you have foam insulation forms with your concrete that you can pour into. And then we have what we talked about with the advanced framing. So if you're not going to have that continuous insulation on the outside, you're going to have to look at a set of specific areas to make sure that you are properly allowing areas to be insulated. So one of the first areas to look at would be the corners of the house. So a lot of times you'll see, just packed in studs at this corner where you can't insulate to the edge. So doing an alternative type of corner where either you use drywall clips or a third stud that's turned sideways, so then you have a nailing surface. That gives you the ability to insulate behind out to that exterior stud. So that's something that you want to put on your plans and make sure that gets done. And the requirement is to get at least R6 out to that edge. Headers above windows and doors on exterior walls. Again, a lot of times you'll see that area uninsulated. So having insulation, maybe if it's sandwiched, sometimes we see them push have the insulation on the inside. All the studs, the framing members are together, and then you have the insulation on the inside. The only exception for this would be if you needed solid wood headers for structural reasons. Then you would be permitted to do that. But anywhere where you don't need that, you'd want to have some type of insulation in that header. And the R value depends on whether it's 2x6 or 2x4. Window framing, a lot of times you'll see just a bunch of excess framing members around these windows. So we want to have a window where you're having your king stud, your jack studs, and then your on center studs. You know, you limit the amount of extra framing members that you have there. And again, if there's a structural reason for a certain stud, then that would be permitted. But everywhere else, we want to limit the amount of framing so you can insulate all these different kind of bays. Exterior and interior wall intersections is another area where, you know, oftentimes you'll see studs packed in there so you can't insulate. So using a technique here, which is called a ladder framing, that allows you to insulate behind that intersection to the same R value as the rest of the wall assembly. So that's a technique you want to use at your exterior and interior wall intersections.
The ladder has wood studs going all the way through to the back half of that. Is that what's going on there?
Yeah, this is a wood stud here. It doesn't.
And that has the same R value as the column right next to it.
Well, this is the same bad insulation. Yes.
Yeah, but with wood stud there, now you have.
I don't know if that wood stud's going all the way through. Sometimes it's just a nail-in surface that is turned one way. So, yeah, this would not have the same exact R value, but it's the intent of your, you know, oftentimes you'll see just studs there with no insulation, which is what they want to avoid.
Okay.
And then sealants. So oftentimes you'll see insulation that's really, once you get out to your edge of the top plate, that's completely compressed. So incorporating a raised heel truss allows you to fully insulate all the way out to the edge of your top plate at the same level as the rest of the house. So something like that would be good. Same thing with a slope seal in there. You can have a raised heel scissor truss. If not, what you want to make sure is that you have at least the R value of R21 out to the edge. So you want to at least make sure that you have that much space with your wind baffle. And then maybe we always want to seal those top plates, so some sort of spray foam plug there always works well. So the requirement is R21, so you can accomplish that through a raised heel truss or allow enough space so that the bad insulation or blown insulation can get to that level. Slab edge is a popular thermal bridging area if it's not done right. So oftentimes the key area that people miss is this slab edge right here. Oftentimes you'll have your R10 here, and then nothing on the edge. So that allows heat to conduct right through up and above, which is the more critical piece actually. So making sure that you're designing to a minimum of at least R5 thermal break on that edge is what you want to look for. And there's Energy Star provides a bunch of details on their website through their training guides and builder guides for all different types of slab conditions.
This one is probably our most controversial detail. And the reason for it is a lot of code officials will see this and they'll say, well, that slab is floating. It's not touching that L block or that L pour on the left side there. And but we've begun to overcome that and can show that the slab's not going to crack away from the foundation, the footing. And also, we got some pushback from our builder clients, particularly as this slab edge insulation has gotten thicker, that they cannot put, particularly in a carpeted area, they can't put their tack strip down up against the wall. There's nothing solid to fasten the tack strip to in order to put the carpet down. So,
and well, there's a solution there where you're allowed to actually bevel cut
right.
the rigid insulation, so you can pour the concrete out a little bit further.
So it does come in contact with it as you go through.
Yep.
But you might get some pushback from local code officials and your concrete installer on this detail.
So that was section 4, which was around framing, slab edge, all those thermal bridge areas that could be problematic. Section 5 talks about just general air sealing, all penetrations, openings, attic access panels. Most of these items, again, have been in Energy Star for a while now, so this is mainly nothing new, but we'll go through some of them. So obviously, anywhere we have a penetration that goes into unconditioned space, you'd want to seal that. So one of the bigger problems is how big of a hole people leave behind makes it a lot difficult. So that's something you want to...
Farmers with chainsaws.
Yeah. So, you want to build these into your processes to make sure that whoever's making the hole is coordinating it so they're not making it really problematic for someone to come back and seal that hole up. Any plumbing pipes that go through into the attic, things like that. Electrical wire penetrations as they go through, those need to be foamed. If there's recessed light fixtures on your attic top floor, they need to be what's called ICAT labeled, which means its insulation can come in contact with it and they're airtight. So specifying those in those types of situations. Some other areas, the foundation to the sill plate joint needs to be sealed. We want to have continuous top plate and sealed blocking at that top plate. Around your windows and doors, those rough openings, sometimes people will just stuff insulation in there. That's not going to do anything. We want to have some sort of air sealing material in there, whether it's Baccarod, caulk, or foam, things like that. One of the newer requirements that Energy Star has introduced is to make sure that the sheetrock to top plate connection at all attic interfaces gets sealed. So here you see the area between the ceiling sheetrock or the wall sheetrock and that top plate needs to be sealed. So this is a high-tech solution where someone's putting some sort of gaskets, foam in there. We've seen you can use drywall adhesive, so you can glue the sheetrock to that top plate. That doesn't work as well because sometimes the installer doesn't do it well. You can go along all the top plates in the attic from the top and essentially seal them all with foam. It's a little bit more labor intensive, but that definitely works the best from our experience. So making sure you have a process where that sheetrock is getting sealed to the top plate is critical. Because if we're addressing all the other areas, that seems to be the most common area where we're going to have leakage coming in at. And then in multifamily situations, where you have a drywall shaft in a multifamily building, that needs to be sealed at all exterior wall boundaries. Multifamily in general gets a little complicated because not only do you want to seal all your exterior walls, but you really want to compartmentalize each unit from each other. So, all the draft blocking or the air sealing that we're talking about on the exterior walls with multifamily, you really want to pay attention to those adjoining walls between units and common areas, things like that. So you really want to compartmentalize each unit as well, so that becomes pretty critical.
We saw a recent study that showed that the reason that tenants, renters move out of multifamily buildings is not because of high energy bills. It's because of smell and noise that moves between units. So if we can convince our clients through the Energy Star Homes program or our LEED certification program to compartmentalize their multifamily units, in the end it becomes a much more valuable building for them when they go to rent it out. They'll have less turnover. So if anyone's interested in getting the information on that study, we have it somewhere in the office. I'd be happy to get it to you.
And then attic access panels or pull-down stairs. You want to make sure that attic access or stair is gasketed, weather-stripped, and has some sort of insulation adhered to it as well, so you don't have a void in your ceiling insulation panel there. So that's it for the thermal enclosure. Any questions about any of that before we move on to HVAC? Okay. Biggest changes from Energy Star that has been, a struggle to overcome a lot. So the HVAC checklist is broken into two checklists. One is for the contractor to fill out, and one is for the rater, the third-party rater, to fill out. So it requires the HVAC contractor or the contractor and their engineering team to design and install a ventilation system that meets ASHRAE 622, which we'll talk about in a little bit. It requires them to design your HVAC system according to ACA manuals, so we'll talk about that as well, but that talks about proper sizing. And then also it requires the contractor to complete field test and inspect the installed system. So there's a little bit of HVAC commissioning done by the contractor. That's a requirement of this. So the first section deals with whole building mechanical ventilation. So as we're building these units tighter and tighter, since the whole thermal enclosure checklist, we're trying to air seal the building, we want to now make sure that we're introducing fresh air somehow. So there needs to be some sort of continuous type of mechanical ventilation introduced into the home. Qualifying types that we see in this region typically is you can do an exhaust-only strategy where you could have a bath fan, for instance, running continuously, which would introduce makeup air through cracks and holes. The downside to that is you don't know where the makeup air is coming from, so it's not a controlled source. The upside to that, it's very low cost. You can get an Energy Star labeled fan. It's going to consume very little power, and the fan itself to install is not that expensive. We see that strategy employed a lot. Sometimes we'll see that strategy employed with some sort of controlled makeup air pathway. So someone will design some sort of passive air intake that will allow the air a pathway back in. So there's all different types of techniques we've seen there. You can have a supply-only system where you're bringing in fresh air into maybe your HVAC system and you're circulating it through the ductwork. The key with that is, though, when there's no demand for heating and cooling, you have to have a controller or a strategy where that system can cycle on and off as needed to provide that fresh air. So the big downside to that is you're using a pretty powerful fan to circulate that air, while an exhaust only you're using a Energy Star labeled exhaust fan that's a couple watts of energy. The plus side obviously is you are tempering that air and you're distributing it. You know where it's coming from. You know it's directly coming from outside. And then the optimum solution, which is the highest cost, obviously, is the balance, as some type of balance system where you can exhaust out air, bring in air at the same time, and you can mix it and exchange energy, get some energy savings out of it. So there's HRVs and ERVs available that do that. Again, they're high cost, but I think as the costs come down, that's something that more and more people are going to want to explore. We talked about the proper design of these systems, so that you need to follow ACA's manual JDNS. J is a procedure from ACA on how to calculate the heating and cooling loads of the house. Manual D gives you guidance on how to size the ductwork, and then Manual S gives you guidelines on how to select the equipment. So the contractor has to follow these guidelines in terms of sizing it, or the engineer, and then document it on this checklist that they did that. And then obviously whatever selected cooling or heat pump equipment gets installed, you want to make sure that that system has a proper rated match in terms of efficiency. Organization AHRI rates a combination of a condenser and a coil and says, okay, with this condenser, coil, and furnace, it's 15 SEER. We want to see that rated match, that documentation. And then obviously proper sizing. You want to make sure that you do all that manual J calculations to get your proper loads, but then you want to make sure you pick a piece of equipment that actually is sized appropriate and you're not oversizing considerably. Same thing with the furnace. You want to make sure that you're properly sizing those based on your loads that you were doing. Refrigerant testing calculation. So the contractor has to do a refrigerant charge documentation and document that that was in compliance with the goals of that equipment. So that all needs to get documented on this checklist. They need to take electrical measurements, confirming that everything's within manufacturer's specifications, and then perform airflow testing. So that's been removed? Okay. Then they no longer need to take electrical measurements.
No electrical measurements, and the airflow test is just at the unit. They don't have to test at the ducts. It's a recommendation, not a requirement.
Is this in the...
Revision 8.
Has Revision 8 been released yet, though? Okay, so what's coming is good news, is they don't have to do the airflow balancing, which we're going to talk about. So Energy Star, good thing to mention, we have version 3, but then every so often they'll release revisions. So right now we're under what's called Revision 7. So everything I'm presenting here is based on Revision 7. I'm aware of a lot of the changes of Revision 8, and that's coming soon. I think maybe June, something around
June 10th or the 19th. June
10th or 19th is where it's going to be coming out. So a lot of this stuff...
I'll pipe up whenever it's something that's going to pick out.
Okay, he'll pipe up. There you go. So right now, as it stands, the contractor is required to measure airflow at the unit and then measure airflow at each register. So it sounds like an Originate, the option, at each register is going to be an option for the.
In either case, it's a good idea.
Yep.
At least on the model home, if there's a model, so that you can make sure that the design is functioning.
So that's the contractor checklist in a very short summary. It's a pretty detailed checklist, documenting the installation test, the refrigerant charge, and all of your design decisions. The radar checklist, which I believe is going away in Revision 8, for now, the third-party rater has to review the contractor checklist for accuracy and certain different parameters. And I believe that piece is going away in Revision 8. So, but for now, that's how it stands. And then there's a section for the rater to assess the duct quality installation. So we're going to be out there and reviewing the ducts to make sure there's no kinks or bends, no excessive duct work, no flex duct work is supported properly. So we don't want to see, flex duct where it's wrapped around like that around a framing member there. That's a big kink that's going to restrict airflow. We don't want to see all this excessive duct work crammed in here. We want to see it properly, sized and coiled and looped. And we also want to see it properly supported. So for flex duct work, we want to see support every so often feet according to SMACNA guidelines. I think it's 5 feet for a flex duct that you want to see supported every so often. We also have requirements for bedroom pressure balancing. So you can accomplish this in a couple ways. You can have a dedicated return duct in each bedroom. You can have a hard ducted return into each bedroom, which is the optimum solution, but expensive. If you have a system, maybe in a multifamily building where you have a central return right at the unit, then you would most likely need to introduce either transfer grills or some sort of jump duct to allow that air to get back into the unit so you're not overly pressurizing that room. And not only do you want to have transfer grills, we want to have them properly sized. Sometimes we go out there and they throw a transfer grill in there and we're still measuring, a pressure difference of like 7 or 8 pascals. So the requirement is to have a measured pressure differential of less than 3 pascals between the bedroom and the house. That bumps up to 5 in certain conditions if you have a lot of supply air. But you want to make sure that those transfer grills are properly sized based on the amount of supply air that you have in that room.
Is it acceptable to undercut doors?
The undercut doors will contribute to that. I can tell you if you're relying on just the undercut door, you're probably not going to achieve the target. It would have to be a really undercut door.
It's typically 1 square inch per CFM relieved. So if you typically have 100 CFM going in the bedroom, we need 100 square inches, which would be, an 8 by 12 grill there, or an 8 by 10 with an 1.5 inch underneath it, 2.8 door, just 20 inches.
But you can count the undercut into your calculation when you're sizing your transfer grills. I know a lot of people with transfer grills, one of the biggest things that they want is sound. That's the biggest issue with them. So some people use high lows. They have some acoustical transfer grills available. That's something you want to keep in mind though, is in your selection process of that. Duct insulation, we're looking for R6 with duct work in unconditioned spaces. Total duct leakage. So for duct leakage, we do 2 tests. We do what's called a total duct leakage test, and we do what's called a leakage to outdoors test. So the leakage to outside is a way where we can utilize a blower door and a duct blaster, which are the 2 testing materials that we use, and we can offset any leakage that's leaking into the house. So the only leakage we're measuring is leakage that's leaving the house. So that would reflect energy loss. So this would be leakage of your duct system that's not getting to your house anywhere. So the target for that is less than 4%. It bumps up for smaller homes, so keep that in mind. But it's 4% is what we pretty easy can get most homes down to 4%. That has not been a problem. If you're sealing it well with mastic, sealing all your boots to sheetrock connections, it's pretty achievable. It also encourages you to design your system where all your ductwork is inside conditioned space. We're seeing more and more of that where you're not having ductwork in attics and garages where you can, through drop soffits and things like that, we would encourage that type of process. Then we do a total duct leakage test, which measures the leakage completely of the system. So even if it's leaking into conditioned space, it's still showing up in this test. So that is 8% of conditioned floor area. There's some other minor, I'm not going to get into the details if there are some variable values there. And with homes with dedicated return ducts, that's been increased to 12% because they acknowledge that you're doing a good thing by ducting all this extra return duct work, but it makes it a lot harder to hit that 8%. So they've given a little bit of leeway there.
We work with Cahill Manion on their designs for HVAC. They have made a decision after all these years of issues that wherever they have the opportunity with a redesign, they're bringing all the ductwork inside the conditioned area. So they're conditioning attics and the ductwork's in there, so nothing is really outside, so they don't have to deal from a code standard, because there is code requirements for this now as well in 2009. And if they do decide to participate in a local Energy Star Homes program, this is not a problem to meet it all. So we're seeing that kind of evolution in ductwork design.
Is there any flexibility in this for rehabbing historic homes?
Flexibility in terms of just the duct leakage requirements, or in general, the whole program?
Both, actually. But this one sort of particularly made me think.
Okay, so yes, there's some flexibility. So for rehab homes, it is a lot harder to achieve. I would say mainly the biggest issues are the water management checklist items, which we're not going to talk about too much today, and some of the thermal bridging requirements. For instance, if you have a slab that's not being touched, insulating that exposed edge there is a problem. So Energy Star has provided some alternative solutions through that. There's a whole bunch of footnotes in the checklist that have specific options for compliance for rehabs that highlight. So they do acknowledge that, but even with those exceptions, from our experience, it's still been pretty difficult to get rehab homes in full compliance with Energy Star. So it is an unfortunate case right now where it's pretty difficult to do that. And just to give you a reference, the 2009 IECC leakage to outside is 8%, so Energy Star is half of that. As codes get ramped up, that's going considerably down. 2012 is down to 4% total duct leakage. So this is where it's all going, is tighter ducts, tighter ducts. So even just for code compliance, that's going to be the case in the future. So how do you get to these levels? We recommend a mastic compound instead of tape. It's more durable. It lasts longer. It's you can paint it on, making sure you're going all the way around the ductwork. The big connections between your duct registers and your sheetrock that's probably the most popular area where we see people miss. So that's the first thing when we're failing duct leakage tests. The first thing I start doing is pulling off registers and grills, and we'll see gaps like that. So that so sealing those connections at your subfloor and your sheetrock connections, sealing the air handler connections as best as possible. Airtight air handlers, they're starting to be introduced, even air handlers that are even tighter and tighter. So anything you can do with specifying equipment, we would encourage you to get down to these levels. Ventilation controls. We talked about continuous ventilation. So there's a couple different ways you can either have a ventilation that's running continuously. In that case, you'd want to have some sort of override switch available. But you also need, if you don't want to do that, it could introduce some sort of control that cycles that fan off and on throughout the day automatically. There's the AirTrack. These are wall switches that go behind your wall plate, and you can program them in to set the amount of ventilation you need, and it'll cycle that fan off and on throughout the day every hour to get that level. And these fans are so quiet you can barely hear them if you're doing that exhaust-only strategy. So there's requirements in the checklist documenting those ventilation controls. Air inlets and ventilation sources, another section of the checklist. So we don't want to see an exhaust outlet, right next to an outside air intake. Kind of obvious things. But there's key kind of requirements documented in those checklists for that kind of focus. And then, so we talked about continuous exhaust, but there also is requirements for local exhaust. So in every bathroom with a shower, you have to have some sort of ventilation, that either intermittent or continuous. In kitchens, you have to have ducted ventilation to the outside. So that would be either a ducted range hood or some sort of other fan that's in that kitchen area that's ducted to the outside. And also, the rater not only documents that these systems are installed, but we measure the airflow. So we're making sure the same things with all the ductwork. You want to make sure you're doing the same practices with your ventilation ductwork, because the rater is going to be measuring it, make sure that you're getting the amount of ventilation that you actually are designed for. Ventilation exhaust fan ratings, we're looking for Energy Star labeled for continuous fans, combustion appliances, we're looking for power vented, direct vented, no atmospherically vented equipment inside the home. MERV 6 for filters. We want to filter the system as well, so they have a MERV 6 requirement for your filter and your HVAC equipment. Filter slot needs to be sealed, things like that. So, any questions about HVAC? Okay. Is what's called the Water Management System Builder Checklist. So this is the checklist that is documented. You're shaking your head.
No, checklist.
Oh, in revision 8, it's not going to be a checklist. In revision 7. So in revision 8, this is going away. In revision 7, though, they did, in all the other previous revisions, we had a checklist where the builder would document that they have properly water managed site and foundations, properly water managed walls, properly water managed roofs, making sure that you're using proper building materials that aren't going to get that handle water properly. So this was a builder checklist that the builder was responsible for verifying. It's going away in revision 8, but it's definitely all great practices that I would encourage everyone to. Most of them are code requirements anyway, I would say.
So essentially it was code requirements that Energy Star was putting into a checklist. What had happened was it was becoming the thing where the site supervisors were just filling it out at the end of the process because it was taking place at 4 different key points when the house was being built. The foundation, when you had your window guys putting on, your roof guys there right before drywall came up. So there's expecting the site super to keep one piece of paper on him for 4 months in his truck is unreasonable. And so it was, Energy Star has taken the stance that builders don't want to build houses that leak. Typically, so rather than have some paperwork that was documenting it, builders now say that I'm building a house that won't have leaks, and if it does have leaks, I will take care of it. So it's still out there as a resource.
Yeah.
It's something to worry about.
It's a great resource, and as he mentioned, it is mostly all code requirements anyway. So it's not like Energy Star was introducing too much new stuff here. It was just more of the paperwork process and part of it that became a hassle. So to recap how Energy Star kind of works with Performance Path, we have your Energy Star HERS index target that you want to achieve through the modeling. So you would work with a verifier, a rater, to do your energy model, come up with a package of upgrades that gets you to that HERS index target. And then right now it's the 4 checklist. It's going to look a little differently in revision 8, which is coming out in June, but you would incorporate all the mandatory requirements of these checklists, and the rater would come out and verify those. The contractor would verify all his items, and the builder would verify all the items that they're responsible for. And at the end, the rater will collect all the data, all the checklists, come back and issue their certificate, do a final energy model, and issue those certificates as well. So what's next for Energy Star? So there is, a lot of states are adopting the 2012 IECC and 2015 IECC. So Energy Star has released Energy Star version 3.1, which is out there now for, certain states are required to comply with that right now in order to get the Energy Star label. That's 15% better than 2012 IECC, and the way I understand it, it is the same checklist, it's just the HERS index target gets dropped down. So if you had to get to 75, it's going to be maybe pushed down to 65 or something like that. It's all going to be through the energy model. There's another program out there through DOE, the Zero Energy Ready Home, where you're building homes that are high-performance homes that are designed to be zero energy ready. So the idea here is you get the HERS index down as low as possible, And this house now is set up where if you added a PV system, you could offset all your energy and be a zero energy type ready home. So that's a program that's getting some traction as well. As the codes go up, this is kind of where all these above code programs are starting to move towards.
In 2012, IECC is from the insulation envelope standards is about 22% more stringent than 2009. Eventually 12 will be here. They're talking about in New Jersey dealing with 12, actually the 15 codes in front of us. And if the states do not comply within a given period of time for upgrading their state energy code in compliance with the feds, then the feds doesn't give the money from DOE. That's the whip. So we expect that the codes will go up and we'll be right next to it.
So I think Rick was going to come up now and talk a little bit about PICO.
Yeah, before Rick, I just want to wrap up our end of it. Thanks, Brian.
Yep.
So to go back to my original conversation, we'll be real quick. The ladder is this. The energy ladder for improved building is code, and then you can just do a HERS score if you choose. So that would be the next step, getting a rating, getting things tested. Then the next step would go to Energy Star. So you can go up that ladder. We are kicking off this month. We announced it last week at the, couple weeks ago at the ABC show in Atlantic City. Our company will be offering, if you do a HERS score and or Energy Star or a LEED compliant building with us, we will provide you, and it's a transactional deal. We will provide you, your home buyer, with a 2-year guarantee on their energy bill. Heating, cooling, hot water, and electrical use. It's backed up by a national warranty company called Bonded Builders. They're our partners with this. So we will be able to offer to you, if they go over their usage that we predict through our HERS score, through the process here of Energy Star HERS, we will guarantee their usage. So if you're interested in talking to us about that, see Lila or Mike out here. There's a brochure out there for it. We think it's an exciting offering. We are the first rater in the country to be offering that through a warranty company like that. So we're kind of excited about it. There should be some press releases that hopefully you'll see about it soon. So talk to us about it. Rick?
All right, guys, I'm going to go relatively quick. So Rick with PICO. And so PICO has just launched a program to give incentives to builders to build Energy Star houses. So basically how the program works, if you build an Energy Star house working with McGran or another rater, get your house to Energy Star, PICO will provide a rebate straight to builders. The rebate amount is $400 plus 10 cents per kilowatt hour saved. We're saying how much kilowatt hours does an Energy Star house save? We found the average incentive range for a house is somewhere between $650 and $850. And what we can do before you start the house is we can model it, figure out how much savings you get. One way to think about it, we're going through each CFL that you put into your house gets you about $3 in incentives. So if you have a typical house of 50 light bulbs, you're looking at an additional $150 in incentives plus the $400 there. And then you're going to get savings from all your duct sealing and all the good stuff that Brian was talking about earlier. That's pretty good.
Was there more slides supposed to be there?
No, this was it.
Okay.
So, but please come up to me after. Be happy to talk about how the program works. It's a really simple process. Basically, you sign a one-page agreement that you'll be building Energy Star houses, and then you load each individual house with address and some more information in. And then a check comes to you guys on a monthly basis once the houses are completed, and we have all the Energy Star information. So,
Nobody asked the big question, how much more does an Energy Star house cost? It depends. That's always our answer. And it's not a smart-ass answer, it is, but it's not. It depends on where you are in comparison to the standards now. For a lot of our builder clients, it's not a big leap, it's not a big upgrade. If you're building basically just a code and that's it, and you're not really paying attention to the rest of the market, what your neighbor builders are doing in their projects, then you're probably this is probably gonna be a leap for you. But generally, we're looking probably at something in terms of hard cost only, not including the cost of our rating. And hard cost only, it's generally much less than 3% of your total hard cost for the project to go to Energy Star. So it's almost a no-brainer if you can get the right contractors on the job, and then you take advantage of the rebate.
PICO will do
Thanks.
sales training with your realtors or your sales staff. We'll come in and help train subcontractors, insulators, framers, and that such. And we'll help cost it out for you too. Make sure that you're optimizing your costs so that you're not spending $2,000 to do it when you can do it for $1,200. So we're there to provide all that support alongside with your rater. So.
Thanks, everyone. Have a great afternoon.